Oppositely, we have to think about small scale also. So sometimes we have to reduce, we have to scale down the big things into small things. And the thought of making the bulk material, the big things, the bigger size material into the smaller size, that is scale down the material, is nothing but we are thinking about the small material, and that material is called as a nanomaterial. This nanomaterial can be used for various applications. As the time changes, any device which is bigger in size initially can be reduced to a portable size that we can easily carry, and it has a lightweight, low cost. So this way we can reduce the size. Airplane, we can increase the size because we want to be bigger space for many people that can board on the plane. But the mobile phone has bigger size and it changed into smaller size. So it happened because of the things which has been used in this phone and in this phone. The smaller things has been used, the size is get reduced. So big things convert into small things. So this type of evaluation we have seen in the devices. There are many examples of such kind of devices which were bigger in size, and now you can find in a smaller size. Now, if you remember, I also told you about the nanomaterial that our eyes cannot see, but you can imagine how big nanoparticle is. I have given the example as shown in the slide. We started with the 1 meter and coming to the Armstrong scale. So size does matter, and this size is useful for some kind of applications. Nanomaterial can be used practically in real world. You can find the use of nanomaterial in various areas such as sunscreen, stain-resistant clothing, tires, cosmetic, electronic, and medicine. These are the different applications of nanomaterial. These nanomaterial has been used in this product. So whenever you are buying or using this product, remember these products are made up of nanomaterial. So nanomaterial has an importance for real life world, and we can use those nanomaterial as a part of these devices or things that are really used in our day-to-day life. Not only from medicine, but it is electronic, cosmetic, tire, automobile sector, and other application also. The next lecture was about size and shape. There are various size and shape of nanomaterial. Why this different type of size and shape is required, or why we need such kind of different size of nanomaterial is required. Sphere, circular nanoparticle, spherical nanoparticle, or cubical nanoparticle, tube, nanotube, hexagonal platelet, or simply cube, platelet-like structure, or tetrahedral also, star shapes, or simply nanoparticle. There are different type of nanoparticle that can be synthesized in the laboratory. If we synthesize these material in the laboratory, each material have a different type of property, and that property is applicable in various devices. So that is the special features of these nanomaterial. To understand this, why we are making these nanoparticles in small size, why these nanomaterial are so much important. So, nanomaterial, this was one of the example I have shown to you about gold. Why gold is always shown? Many times you will find this is the classic example, because you can get a different kind of color, and that is the optical property of gold. Initially, this gold material, when you talk about the gold, some of you might have gold on your body. So this gold is yellow color, but when it convert or transform or reduce into small size, that is at nanoscale, you can find those nanoparticles behave differently. And you can get such kind of color combination as you change the size. Yes? Yes. No, different color, because we cannot get that one, like you can have the small kind of powder and you put it. So that this is the optical absorption, okay, that individual particle is giving. Otherwise, we will make the gold bar in different color. Okay? That will be another. So woman will like that. Okay, gold in different color. That will be fancy word for woman. But this is on, even to make this bar, you need a big nanoparticle. And nanoparticle need a bigger space. Okay? So if we want to make this kind of, it need 100,000 times more space than this, because we cannot easily compress the nanoparticle. So this behavior we can see, we can observe in the liquid medium. It can show the color. This is because of the optical absorption. That is the optical property of nanomaterial. So nanomaterial has various property. One of the property is size. Size dependent of nanoparticle that can show a different behavior with different color. Now, beside the size, I also told you about reactivity. Reactivity is another property of a nanomaterial. So, nanomaterial has two basic property. Beside these two basic properties, such as size and reactivity, each nanoparticle, whatever nanoparticle we prepare in our laboratory, they exhibit a different type of property. What are those properties? Particle size and shape, that we already talked about. Size distribution and agglomeration. So size distribution means sometimes some nanoparticle has equal size, some nanoparticle has maybe 20, 30, 50. So size is not homogeneous. That is how the nanoparticle size of prepare nanoparticle in our laboratory. So sometimes size variation also occur. It is not like 50, 50, 50. Sometimes it is 30 nanometer, 50 nanometer, 80 nano. So in that case, we say average size is 50. So size distribution, sometimes it is good. Sometimes size variation is not good. Agglomeration. what happens when you prepare the nanomaterial? Usually, nanomaterial attract towards each other and they make agglomeration. Agglomeration means group of nanoparticle collected together, come together. So that is agglomeration. Agglomeration is also one of the property of nanomaterial. Then some nanomaterial has surface and crystalline also. Those crystalline or plane surface, uniform surface, that property is also useful. Whether the surface of nanomaterial is smooth or rough, both are applicable in various devices. Sometimes we need plain surface, smooth surface. Sometimes we need a rough surface. So how that surface of a nanomaterial is? Composition. Composition means how much quantity of certain element can be found in nanomaterial, or if we are making the composites material, how much single element is available in the nanoparticle. Then porosity and surface area. Some nanoparticle has pores. That is their features. And surface area, bigger surface area, like cube has bigger surface area than sphere. So each size and shape of nanomaterial has certain surface area. So some application need bigger surface area, some application don't need bigger surface area. Then surface functionality means reactivity, how it react. So particle shape size and this reactivity are the major properties of nanomaterial that are widely used for practical purposes, and rest of the property are also found in nanomaterial. So these are the properties of nanomaterial, and these properties are different than the bulk material. These properties cannot be found in their bulk counterpart. This was the slide I want you to remember. What is the new about the nano? The new about the nano is not making only the nanomaterial at nanoscale or use the nanomaterial at nanoscale. It is the understanding, what you understand, what kind of features you remember and you use that feature for practical purposes, and how this nanoparticle behave differently. If certain nanoparticle shows tunneling behavior, like electron can move smoothly with less energy, that is the electrical property is improved. Why it is improved? Why this electron move from conduction band, valence band to conduction band? That kind of justification or understanding or knowledge or information you must gain through these nanoparticles. So that is overall study. Don't prepare and directly go for the application. If you are preparing any new material, think where I can use these material, why I can use, whether this property of material is useful. You might think that before preparing the nanomaterial, you was thinking that you will use this nanoparticle for certain application. That was in your mind. But if you get a special property, different property than you expected, then maybe you can change your thought of application and go for another application. So this way, you must understand. Traditionally, we prepare and we directly go for the application. But understanding them is also a different aspect. You can learn many things. You have to search many things about learning the nanomaterial. So these are two different things. One is practical, okay? Making or using is an experiment, is a practical. understanding is gaining the knowledge, sharing the knowledge. So that is very important when you write the research paper. Then we come to the lecture number 3, that was about nanomaterial synthesis. I have explained you there are 2 types of approaches that can be used to prepare the nanomaterial. The one approach was top down, the other approach was bottom up. In top down, larger size is converted into the smaller size, where in bottom you start with the very small particle on nanoscale, and then you can a very small tiny particle, it may be atom, it may be cluster, and then transform that smaller cluster like particle or atoms into the nanoscale size particle. So that is the bottom-up approach. And we also study 8 types of synthesis method. There are more than 20 types of synthesis method. But widely used synthesis methods for preparing the nanomaterials are ball milling, thermal evaporation, laser ablation, sputtering. And in bottom up, chemical vapor deposition, hydrothermal co-precipitation, and sol gel. These are widely, or many researchers use these methods. I hope you might use one of the methods. Of course, if you are using different method, that method is also okay. Then I explain you about photocatalysis experiment, how this photocatalysis work. I told you when you put the light, then charge excite, and after charge excitation, how this charge react with the oxygen and then create the radical, positive hole react with the H2O, creating the hydroxy radical. Those hydroxy radical react with the organic pollutant, and then organic pollutant is converted into H2O and CO2. And this way we can understand the process of photosynthesis. So photosynthesis is one of the application, comes under the field of green energy. Here the main things is radical that can destroy the organic pollutant. So creating radical is important here, that can convert this contaminated water into clean water. Then another application I talked about, photoelectrochemical. Photo light, electro means using electricity, chemical means chemical, certain kind of chemical. So there are 3 different things used in this process of water splitting. So those who do the research, especially on PEC, water splitting, they need certain kind of setup to create the hydrogen. And then next lecture was about the application in optoelectronics. So I explained you 3 different type of application. One was light sources, that is LEDs, solar cell, and photodetector. So we have seen that how the blue LED was created, how they get the Nobel Prize, what was the importance of this blue LED and why they get the Nobel Prize, what was the new things in the LED. And this LED can now use widely. So this is the beauty of such kind of material. So once you make it in the laboratory, if it is possible to make the commercial device, that device can be widely used everywhere. The next application was solar cell. I have explained you what kind of material is used, how principle of solar cell work, how solar energy is converted into electric energy. This is the simple mechanism of solar cell. And in case of solar cell, you can use the perovskite material for solar cell. Perovskite is one of the candidates to make the solar cell. However, at this moment, there are various candidates used for solar cell, especially silicon-based solar cell, but in future, perovskite might be used as a prime candidate for the solar cell. Because of its property, various property, you can see fabrication cost, raw material cost, efficiency. Those property are very important, and in future you might see a different type of solar cell. Third was photodiode, photodetector. There are various kind of photodiode and photodetector, and we can use a two-dimensional material to create this photodiode material. Traditionally, we are just using electricity, but when you put a light, so that light is nothing but photon. So photodiode. This photodiode can sense the light, which is incident on the diode, and then this light is capable for detection. This photo detection can be done using this photodiode. There are several two-dimensional nanomaterial that can be used for photodiode or photodetectors. So two-dimensional nanomaterial are major nanoparticle that can be used for photodetector or photodiode. Yesterday, I talked about the application in the field of medical science or healthcare. The major application involve drug delivery, cancer treatment, nanosensor, nanorobot. And some of the application is already available, and in future these applications can be developed. So those we have seen how the application of nanomaterial for cancer treatment is possible, how they will kill the cancer cell without damaging this healthy cell. So this way is a real world application for the nanomaterial in the field of healthcare. Several applications in surgery is possible where these nanoparticles can be used for various purposes and operation can be done without making mistakes. These are possible applications in the field of healthcare. Now coming to today's talk about future application. What are the future application of this nanomaterial? What is the social expectation from nanotechnology? And present trend that I talked in the class number 1, I will explain you again, and future trend. Of course, some of the slide I have already shown to you earlier. Social expectation means we have some kind of demand to make something for some special purposes. So when there is a demand, scientists started to work to fulfill that demand. That is social expectation. Like when there was corona, everybody was expecting to make the vaccine. That is, all human beings were waiting for the vaccine. Scientists replied to the demand and they created the vaccine. Certain kind of demand always comes. So those demand can be fulfilled by the scientist while making these devices or fulfilling this demand. They use nanoparticle, nanomaterial, nanotechnology, so that our daily life become more comfortable. While using this nanomaterial, as I explained you in a last slide, that nanoparticle has several applications. Beside several applications, those applications are based on their special features, special property. And that property is useful for making the devices. So nanoparticle property can be used whether they are having high strength, if we are thinking about mechanical nanomaterial, lighter weight, when we want to make anything which is lighter in weight, or conductivity, how we can improve the conductivity so that such nanoparticle can be used for electrical purposes in electronic devices, or chemical reactivity, so that these nanoparticle can react with the other nanoparticle or other material, and they can quickly respond. They can perform the quick reaction that can be helpful for the particular application. So nanotechnology is useful in our life. With the help of nanomaterial and nanotechnology, we can find out some solution. That solution is addressing the demand of society. This is one of the example where nanoparticle was used in several occasions during the corona. So what is this? You can see it was not only making medicine or kit infection, but everywhere different type of nanomaterial is used. Why different type of nanomaterial is used? Whether it was only oxide material, only metal nanoparticle, or cellulose, or fiber, or polymer, or lipids, or some kind of two-dimensional material, or liposomes. Each nanoparticle exhibit certain property, and that property can have a different application. So based on the property, their application is designed, and after designing the application, a real world is ready to accept those devices. So this is the application of nanoparticle used during COVID-19. Besides this, we are using some devices in our daily life, but we want to increase the efficiency, the speed, and what kind of areas that can detected or find out that we can improve the property, we can enhance the performance of those devices in various fields. What kind of field? Maybe computer. Computer is increasing, growing fast. Okay, size become smaller and smaller. So components that are used in the PCs, notebook, or even smartphone, their size is reducing because the circuit, which is made up of small nanoparticle, is responsible for reducing the size. So you use the small size particle material, then automatically this overall size of computer will decrease. Another is medical equipment, instrument, that is looking for more faster and functional and accurate measurement of medical tools. These medical tools is very useful in the surgeries or while giving treatment to the patient. So medical is one of the field which is going to improve day by day as we progresses, and the tool, the equipment which are used in the present day when we are dealing with the operation or treatment, that tools, equipment might change or need for faster performance is there, and nanoparticle will address this issue to improve their various property, maybe wear or resistance, so that it can enhance, it can increase, it can improve the, or it can give the faster response, it can do the things more accurately. The third is pharmaceutical. In medicine, maybe there are already nanoparticles used in various medicine. So medicine is one of the field where we make tablet to give to the patient. Now this pharmaceutical tablet, capsule or whatever syrup we are making, they consist of nanoparticle, and it will improve if we started to use a certain kind of new nanoparticle in pharmaceutical product. So it is expected that this nanoparticle can be used for drug or tablet, and those tablet can be given to the patients. Then automobile is the next example where carbon, or we have seen like while making tire, carbon nanoparticle is already used. Similarly, a composite type of nanomaterial that can has lighter weight, stronger strength, and more chemically resistant than the metal. It is a replacement to the traditionally used metal. If we use the metal, it has high weight or heavy weight. But if we started to use the nanoparticle, the weight will reduce and product become lightweight. But while doing this, we have to think about the strength also. Its strength should be equal to the metal or more than metal. Carbon nanotube has higher strength than the metal. The good example of carbon nanotube is making the tennis racket. There they have used carbon nanotube instead of traditional metal wire. So strength is also one of the property that is useful to make the certain devices or equipment. Then in the cloth industries or fabrics where stain resistance should be there, water resistance, like we can use those clothing in the rain. It is already available, but we want to improve it. If we are using certain kind of nano coating in the cloth, but that nano coating is expensive, or due to some reason it cannot be used for longer time. So we are thinking, we should think about using the new material. So here, again, nanoparticle can be used in the clothing or fabric industry, where we can improve the performance and our clothing will become more comfortable to stain resistance or water resistance. Water filter. So dealing with the water is one of the area we are looking for. Water filter is a need where water is not clean and we want to clean the water and use it. But while using this, it must be cost effective. So cost effective, again, come back to the material, because cost of any product is design, is depend on the raw material that we are using. So those raw material should be cheaper, low cost, so that overall cost will reduce, and this water filter can be used with high efficiency that can create the drinking water. The carbon nanotube, I have already given the example while talking automobile sector, where such kind of carbon nanotube can be used in the racket. So in sports application, so this is one. While making ball, whether it is a soccer ball, whether it is a tennis ball, can we use the technology? So there will be demand. So somebody looking for small size, somebody looking for lightweight, anything related to the sports, whether it is bat, it is ball, net, any equipment that is used in the sports is applicable for this kind of nanomaterial to be used to increase their performance. And again, in the cosmetics industries, we are using TiO2 zinc oxide. That is presently available. You go, you can check in the supermarket, they will show that this product might be consist of TiO2 zinc oxide. And in future, it will again improve. We might get a different kind of material that can block the UV rays. At present, we are using zinc oxide and TiO2 because they are more resistive to the ultraviolet rays. So in future, it might happen that some nanoparticle will show better performance than zinc oxide or TiO2. Then we can replace them. Food packaging also, we have to see whether such kind of application can be done to protect the food for longer time. Many drink bottles are made up of plastic containing nano layers which increase resistance to permeation by oxygen and carbon dioxide and moisture. So sometimes some polymer has permeation, they can allow these gases inside also. So those things, practically we can consider how to retain the water inside the bottle or carbonated water, or keep the same pressure when it was at the time of its production. Permeation means it easily allows the gases, it can change the pressure. It can change the pressure also. After a certain time, when temperature decreases, it might change, and if it has permeation, gas might enter because of the small pores. Then chemical sensor, there are many sensors available. If there is something leak, gas leak, sometimes we have like LPG sensor or gas sensor in our home. If there is leakage in the gas, we can see the alarm. So that is gas sensor. So in future, although presently there are many chemical sensor available, but in future this field will be also improve, and the sensor technology can be changed by using the nanomaterial. The present trend, why we are growing so fast, especially the car industries or smartphone industries or aviation industries, these are the growing industry. This is one of the example. You choose any one example. Instead of car, you just choose the smartphone, or you just choose the airplane, or you choose any other application. You will find each device has many small equipment or some kind of circuit or sensor, and those circuit, sensor or part of those devices are made up of nanoparticle. So when you drive the car, the present car, which is automatic car, if you have seen, this car is equipped with many small sensor or maybe display or screen or certain kind of things that require for autonomous drive or some kind of power related devices or battery. Everything you will find in the car. And that is the product of nanotechnology also. The size is getting smaller and smaller, and performance is increasing. So you can look at any one of the field, whether you consider the display. So display is becoming thinner and thinner, the intensity, the brightness is increasing. So intensity, brightness, clarity increases means what? There is a new material used for. If you use traditional material, then it will not show the brightness. Or it may be traditional material, but combined with another material so that the brightness, the other feature can increase. So display, batteries, sensors, monitors, these are various parts that we can see in the car, or even tire. Okay? Tire is also a part of nanotechnology. Carbon nanoparticle is used in the car tires. So this is the example that can be found in present day, and how these problems can be seen in the laboratory. What kind of research globally is going on, and research in Japan is going on. Globally, these are the main area where scientists are working, and in case of Japan, they are working on this kind of application. Application in the global market: power semiconductor, storage device, 3D printing, IoT, quantum computer, data storage, optoelectronic devices. These are major applications. If you look at any research paper in the field of material science, you will find that one of the application is useful for the nanoparticle that has been created in the laboratory. So each paper consists of certain property that comes under this application when we talk about the nanomaterial. So nanomaterial is used globally for various applications. I just show 7 because that are widely, if you choose any 100 paper, most of the paper consist of this. But besides this, there are other applications also. That does not mean that they are not important, but these are on the top. Similarly, in case of Japan, they are working on organic solar cell, because in Japan solar cell are quite used. Storage devices. The storage devices means data storage devices. OLD, organic light emitting diode, to increase the performance of display. Photonic devices, photocatalyst, battery devices, robotics, AI, and IoT. Japan is now started to work on this. Of course, they are very good in robotics, but AI, IoT is growing up now. Traditionally, they were good in robotics, and these are the new, relatively new field, even photonic devices. In future, the use of light, whether it is solar cell or other light, or the devices which are based on the light technology will be more in the future. So such kind of application is considered, whether it is optical switching, optical communication, metamaterial, everywhere you will find the nanoparticle. Now future application. What are the future application? Even I am talking with you from last 30-40 minutes. I shown you several applications. Even though I told you that medical application we can see practically during COVID it was used for so and so application, then why I am telling again it can be used for medical. Those applications are already exist or at present scientists are working. But in the future, after this current trend is over in next 5 years or 10 years, what will be the future application for the next generation will be in the medicine. As I told, if you remember the lecture given by the Feynman and Higgs, they says that if we started to make nanorobot that can goes in our body, or if we can control the atom and we can put them as we wish, then such kind of application in the field of nanobiotechnology is possible. So, nanobiotechnology, nanomaterial used in biotechnology. So, this is possible in future. Energy, renewable energy, solar cell, different form of energy in the form of light. So LED light, flexible energy sources is possible in future. So those application in the field of energy is also useful. Then electronic devices, this size is getting smaller and smaller. Now if you find this size maybe 2 centimeter by 2 centimeter or 3 centimeter. But earlier same was maybe 6 centimeter by 6 or something. So at present we are again want to reduce this size with improved performance. While reducing the size of this electronic component, we will improve the performance. So reduce size and increase the performance. That is the target. Reducing size with the same performance is not useful. It should have some kind of higher performance, better performance. Then such devices can be widely used in the future. Then in chemistry, so for protecting our environment, we should use a certain nanomaterial that cannot create pollution, that cannot be harmful to the environment. Such kind of nanoparticle will be considered while making or while preparing this nanoparticle, so that they cannot react with something that can create the byproduct which is harmful. Consumer product, there are many consumer products are good in the field of cosmetic also, not only the sunscreen but other thing that can be a part of cosmetic will be useful when we think about using the nanoparticle. And to change the gene technology of fruit, plant. So such kind of research is going on, how we can improve the production of this fruit. If we change their gene, whether we can grow them faster, if we do not grow them faster, but with more nutrition. That is the research conducted by the biotechnologist people to improve the production rate and even the quality of the fruit or plant. Military and security application, not only the water resistance, but also bulletproof jacket with lightweight. So they are looking for certain material that can use as bulletproof material during the wars. Then in animal and plant health, detect the pathogens to treat the animal and plant while their health is a severe concern. So this detection of pathogen in the animal and plant is also one of the area to be addressed in the future. Plant production, so how we can improve the overall production of the plant by dealing their DNA. So whether we can change the DNA, whether we can add certain DNA to them, and if we successfully add the DNA into the plant, then it may possible that we can increase the crop productivity. Animal production, so nanotube sensor to detect the hormonal level changes. So some kind of sensors can be used to see how we can improve the animal production. Last 2-3 slides now. Agri-chemical, some of the country don't use pesticide, but the country, those who are using the pesticide, there you will find a certain kind of nanomaterial is used to increase the crop productivity or protect them from some kind of maybe insects. And food industry, whether it is sensing or safety or packaging. Packaging is one of the growing industry to protect the food for longer time. How we can protect the food? What kind of material we can use for protecting this food? Because, for example, in India, it is a warm weather. So when we are carrying one food from one place to another place, due to the temperature, it is difficult to carry. So what kind of packaging we can make for such environment is a challenging. Once we come out with some solution, then we can prevent to respond to spoilage. So that food cannot spoil if we improve the packaging. Safety, how we can detect the impurities in the food. So that is also one of the challenge for the scientist in the future. And sensing the food, like detect chemical or foodborne pathogen. So those sensor is required for food industry while creating the product, while detecting such kind of pathogen. Stages, we are in 2020 to 2030. The next, this 10 years until 2030 is up to robotics and 3D network. And from 2030 to 2040 or maybe more, it will be to the molecular nanosystem. Molecular nanosystem means where we are controlling the atom. If we control the atom, this means we can able to create the molecule system. So molecule system, if we succeed to control the molecule, then we can able to make the smaller devices. As it was predicted in 1959 that if we control or if we arrange the atom in a certain way, that it is possible to make the device of our choice. So that will be the future challenges after 5 years or 10 years. So those challenges involve the battery, smaller battery. But devices will be very small. When the device becomes very small, you deal with small kind of storage device. How you will make this? That will be the new challenge. Okay? So now we are talking about the nanoscale. But when it will come to make the devices at nanoscale, that will be more challenging to support. For example, making this battery. If we say nano robots, then who will provide the battery, or how we can provide charging to them? That kind of question, not only in the sensor or robots or computer, television, everywhere we need to address this problem. As well as water cleaning, we have to think about the photocatalyst or any kind of nanomaterial that can use to clean the water. And in the future, we are expecting computer that is based on the quantum phenomena, quantum computing. So for that, we have to make the very tiny small devices with high performance, and that can be fulfilled by quantum dot. So quantum dots is having very small size, and that quantum dot can be used, or whether we can create artificial atoms. If once we understand how atom is created, so is it possible that we can create a certain artificial atoms to make such kind of small devices? That will be the future challenge. So with this, I am going to stop here. Thank you very much. If you have any question about today's class, about last 6 class, you can ask question now, or maybe after the class or during the break. I am ready to answer your question. Thank you.